Hey everybody, it's Miss Kennedy. I'm back with a review video. I know I have not made very many videos recently, but I feel like I've been giving pretty boring assignments, so I wanted to go back to something that we're all used to. That's me talking. So this is just going to be part one. There's two parts of Unit 6 review that I'm going to make, so this is just the part one video. And it's just kind of focus on an overview of energy, and then just specifically non-renewable energy sources. Part two will be about renewables and a few other things. So I hope you enjoy. And I just want to start with something a little sentimental and say that I really love teaching you guys, and no matter what the results of the AP test are, I am super, super proud of you. And I know some of you are stressing because the test is coming up soon, but don't put so much pressure on yourselves. I hope you get 4s and 5s, but I also just want you to be proud of how far you've come and know that teaching you has really been the highlight of my career. I've loved every day, every minute of being your teacher and seeing how you guys kind of respond to the worms, to nature, to me. It's been so awesome, and I really, really miss you all so much. So don't put so much pressure on yourself about this test. It's just a test. And I didn't even take this test in high school, so keep that in mind. But for real, from the bottom of my heart, I love all of you and I miss you so much. All right. Okay, so basic overview, non-renewables versus renewables. I think you, at this point, kind of know what they are, hopefully. If not, I'm just going to go over it super quick. Okay, so renewable energies are from natural sources. They're not, made up out of technology. They're from the wind, the sun, the water, all that stuff that comes from our land, and they can be replaced over time. So we're never going to run out of sun, we're probably never going to run out of wind, anything like that. They're going to stay on our planet so we can keep using them for energy. So they're renewable. Okay, and the examples are solar, wind, hydro, geothermal, and biomass. So we're going to get into those in my next video, but those are our renewable energy sources. They can be used over and over again. They can be replaced over a short period of time. Non-renewables, on the other hand, they come from resources that are also natural, but they can't be replaced. They don't regenerate like the wind or the sun, which is constant. They're replaced really, really slowly over millions and millions of years. So when we take them, we've kind of lost all of them for millions of years. So we won't see any more coal or oil once we run out because it takes millions of years to generate. Okay, so these are our non-renewables that we're going to get into today: oil, coal, natural gas, and nuclear. So they cannot be replaced. They are natural, but they take a long time to make. Cool. So just a few trends in energy consumption that I want you to think about. They might ask this kind of stuff on the test. It's pretty logical when you think about it, but developed countries like our own, America, right? We consume a lot more energy daily per person compared to a developing country because we have a strong economy, and we have the need and the desire to consume a ton of energy. So we, as a developed country, consume way, way, way more energy than a developing country, and they are not industrialized like us. Their cities look very different than ours, and they're usually poorer in terms of their economy, so they don't consume as much energy. And if they do, it's something like biomass. They're burning wood, grass, all that stuff. But developed countries use a whole lot more fossil fuels because we have the money. We can go out and drill for fossil fuels, and we can recruit, companies to do that for us. But developing countries don't have the access to those resources and that money. So they rely on the cheaper stuff like biomass. Just something to think about. Oh god. All right. So which countries produce the most energy? So pretty much for every single resource except for coal, it's the United States. So coal, the country that produces the most coal energy is China. The country that produces the most oil is the US. Natural gas, the US. Uranium, which is for the nuclear energy, is also the US. And geothermal, which is also the US. So you might be like, well, what about this thing that we did in class where we looked at all these different countries? Some of them you've never even heard of. Why aren't those in this chart? This chart up here is about who actually makes the most energy. So all these countries here, like the Philippines and India, they have tons of these resources. They have tons of coal, they have tons of oil, but they aren't actually producing energy from it. It's sitting in reserves because the countries don't have a strong economy or enough resources to take their reserves and turn it into energy. But which country does have a large economy and all those resources? The United States and also China. We have two of the world's largest economies, so we can take and capitalize on our natural resources, whereas other countries like Venezuela that actually has the most oil, they can't actually be on this chart because they don't have the economy or the resources. But when in doubt on this test, if they ever ask you, like, which country is it, it's most likely the United States, except for coal. Okay. So I just want to briefly talk about how do we actually get energy from fossil fuels, and you can definitely pause and read all this stuff, or if you're like a heavy note taker, definitely get that down. I'm just going to talk about it myself. We talk about energy a lot, but you actually have to stop and think about how do you turn something like oil into energy that powers your lights. It doesn't necessarily come right into your head. But I'm going to explain it with this really confusing looking image. So you can take any of our fossil fuels like coal, oil, or gas, and they'll go into what's called a combustion chamber. So in the combustion chamber, the fossil fuels are basically heated, and they have these special bonds called hydrocarbons. And really all you need to know is that when these bonds are broken, like at the chemical level, when these bonds are broken, they release a large amount of energy. And that energy is kind of used to then heat up water, basically. In this steam boiler, you have a bunch of water, and the energy that comes from the combustion chamber is then heated up and turned into steam. And the steam is really important because it creates a lot of pressure. When you turn water into steam, you get a lot of pressure. Like, think about like a teapot when it boils. It sings a lot because there's a high pressure like change from water to steam. So that high pressure goes through this valve and then into a turbine, which is kind of like a spinning thing. And the immense amount of pressure from the steam forces the turbine to actually rotate or spin. And as it's doing that, there's a little magnet inside that's kind of like a generator. So this is the generator here. There's a little magnet. And as it spins, it creates electrons. And electrons are then used to create electricity, which would then power your electric power lines. Sorry, my face got in the way there. Okay, so all that is literally just to create electricity to run through our power lines. You start with the fossil fuel, it gets burned, that energy then heats up water, the water turns to steam, the steam gets pushed through a turbine, the turbine spins a generator with a magnet in it, the magnet creates electrons, the electrons then power our entire world. So that's, in a nutshell, how you create energy from fossil fuels. And that's really the backbone of almost all energy, including renewables, but I just wanted to go over that for everybody so you feel kind of confident. They are probably not going to show you this on the test, but just know that it is a complex process, but it is pretty much the same for all different types of energy, so yay. Alright, so we're going to talk about coal first and talk about some of the advantages and disadvantages. This is pretty much true for coal and oil, but let's start with coal. So coal, there's a lot of coal on Earth. It's going to last a long time, so there's an ample supply of it, meaning we won't run out anytime soon. We'll see. There's also a high net energy yield, meaning that you get a lot of energy from it. So you burn it, and it's expensive and stuff, but you get a lot of energy out of it. So it's really efficient. It's also low cost with a lot of subsidies, meaning the government's kind of helping people to pay for coal factories to produce coal to make energy. Disadvantages of coal burning coal and mining coal is that it's really bad for the environment. It's very damaging to the land. When you mine for coal, you disturb the entire environment, like you can kind of see here. We pollute the air with tons of different pollutants. When we burn coal, release the pollutants into the air after it's been burned. We also pollute our waters that way. We use a lot of land to mine the coal. Like when we did the cookie mining lab, if you're mining for coal, you're just destroying the whole area around you. There's a lot of CO2 that gets emitted when you burn coal, so that's contributing to our global warming because more CO2 in the air warms our environment. And it also releases radioactive material and mercury into the air. So when we talked about mercury in the water, that's actually a main source of mercury is from burning coal. So it's not just appearing in our waters out of nowhere. It's coming from the factories that are burning coal. So there are quite a few disadvantages of coal. I'm briefly going to talk about these types of coal. You don't have to worry about memorizing this, but just know there are a few different types of coal. And anthracite coal is the most desirable because it has a really high heat content, meaning that when you burn it, you get a lot of energy from it compared to the other types of coal. So anthracite is what most people want to find. And if you look at this map down here, the United States has a lot of anthracite, and so does China and Russia as well. But the more anthracite, the more money you're going to make. There's bituminous and lignite coal. Lignite, it has a really low heat content, so it's not as desirable. And the main reserve is Russia. And then bituminous coal is kind of the middle ground that most people end up using because there's a lot of it. So China and America both have a lot of anthracite and bituminous coal, which is why we are the top two producers of coal because we have so much available coal to burn. So that's coal. Now we're going to talk about oil. Oil is pretty similar in its pros and cons, except that one of the advantages, but technically a disadvantage, is that we have an ample supply, but we will run out of oil soon. In probably not your lifetimes, but we will need to find a substitute for oil, and people are trying to turn to renewables, but eventually our oil reserves will run out. There are, again, low costs with a lot of subsidies from the government. You get a lot of energy from burning oil, and it can be easily transported between countries via ships and pipelines, so that's an advantage. But there are a lot of other disadvantages. So there's a lot of water pollution that I'm going to get into in a minute. There's also that release of CO2 when you burn oil. It's burned from cars and stuff. There's a ton of air pollution. And then this one I think is really interesting, and I speak a lot to my brother about this. He works in the government on different energy projects. But people, because the prices for oil are so low and so cheap, people are kind of like encouraged to make a bunch of waste when they're burning oil. Like, they're not so concerned with the environment because it's such a cheap way to make money and make profit and make energy. And there's not a really big push to search for alternatives to oil because you can make such a profit off of it, and it's so cheap. So there's a really interesting issue there with oil, and we will see it run out. So we need to push for alternatives and kind of get over the fact that we can make a ton of money off of it. And also, if you look over here, you can see how bad it is for our environment. So I'm going to go over 2 oil spills. The BP Deepwater Horizon spill. This is the movie with Mark Wahlberg. Hopefully we'll watch it in a few weeks. It took place in the Gulf of Mexico in 2010, and it was pretty bad. You can tell it had a massive explosion. There was like a leak in a pipe that caused the entire barge, this is like a huge rig on the water. It exploded and then leaked tons and tons of oil that was being mined from the deeper water, and just caused so many deaths between birds, fish, mammals. It was insane, and you can still see the effects today. It was the biggest and is the biggest oil spill in history. Wow, so sorry about my handwriting. Before that, the biggest was actually Exxon. So this Exxon spill occurred in Alaska in 1989. This is actually an interesting story, but the captain of the ship was drinking, and he let someone take over the ship, and they ran it into a reef, and that caused a massive leak of oil. And I mean, you can just see like what it looks like in the water, what it looks like in cleanup. It's devastating, and it kills so much life. But because it's cheap, we still do this sort of thing. So I also kind of have to push back on this one over here, that it's easily transported. Like, sure, it's easily transported, but then when it blows up, it blows up, and it's pretty sad for our planet. So I think you have to take everything into perspective, really think about things before you make an informed decision, but know that there are always pros and there are always cons, and you can always poke holes in both. So go ahead and do it if you want. So I know this video is already really long, but this is a really important element to studying this kind of science, is seeing the impacts of our choices. And this is actually what got me into environmental science to begin with, was learning about these pipelines. In my first college class ever, I learned about them, and I thought it was so crazy, and I wanted to learn more about the environment and other horrible tragedies like this. So it really got me to where I am today, learning about these kinds of issues that aren't just scientific issues, but they're human rights. They're a fight for our entire planet, which I think is interesting. But our oil is transported in these big pipelines like you see here. They run the span of our entire country to get oil from place A to place B. They're massive, and they've caused a lot of problems. So the Dakota Access Pipeline is a little bit smaller than the other one I'm going to talk about, but it runs from North Dakota to Illinois. And there was tons and tons of protests about this because it runs through a lot of indigenous and sacred land, and people were really upset that their land was being taken to create these pipelines. And usually where there is pipelines, there is contaminated water, there can be spills, which is what you see down here. So it can really damage the land and the people around it. So people were protesting because it's not, it's not fair, and people's lives become tampered with, and people get upset. So there was a mass amounts of protesting when I was in college to defend the sacred land, to stop the pipeline from being built. It did not work. The pipeline was built because money kind of rules everything. So there's that pipeline. There's also the Keystone Pipeline, which is massive. It goes all the way from Canada down into Texas, and they're trying to expand it even more. And again, runs through a lot of sacred land that doesn't necessarily belong to big businesses and governments. So there's been mass amounts of protests for both of these pipelines. People have been arrested, celebrities have gone, which is like a big deal. But it's, again, one of those issues like Flint where people's lives are being put in danger and the people in charge don't really care. There's been massive leaks of oil. There's been serious contaminations to drinking water, and people are just getting their land ripped away from them. So it is something that I consider to be a massive con or disadvantage of oil and most fossil fuels. So I think it's important for you all to know. Okay, so the other thing that I also got really into in college was fracking or hydraulic fracturing. This is how we get natural gas. So we call it fracking, and most of you remember that, the fracking song. But it stands for hydraulic fracturing, and it's really bad because it contaminates groundwater, releases methane, and uses tons and tons of water to do it. And I'm going to get into it briefly, but I'm not going to overwhelm you because it is a lot of information. All right, so essentially these hotspots are located where there's a lot of natural gas, and then this crazy looking structure is built for a massive drill to then drill into the earth. And this drill goes like literally 2 miles. It goes so deep into our planet. It actually passes our aquifers, which is like our water resources here. So they'll drill past the water, which then brings up the question of like, oh my God, doesn't it pollute the water? But I'll get into that. So it drills past the water and then actually turns horizontal and goes for about 2 miles. So these drills are, these like massive holes in our earth are giant. So they drill these huge holes and then they take the drill out and then they pump a bunch of cement in, and that cement is supposed to create this like seal so that it doesn't contaminate the water, and none of the chemicals and stuff that are going to come into it get into our aquifers over here. So that's kind of like a safety element that they require. Doesn't necessarily mean it always works. So they drill, cement is put in to kind of create walls to seal it off, and then this fracturing fluid, which is a mixture of water, sand, and chemicals, is then pumped into this massive drilling hole. Okay, so they use sand to kind of keep all these cracks they're going to make open. They use chemicals to kind of flush things out, and for a lot of other reasons that they don't disclose. And they use the water to get it all to run down. So they create this kind of mixture, this fracking fluid, and they pump it into this big well. I'm going to erase some of this stuff. Okay, and it goes all the way down into these areas where there is natural gas and creates these fissures, or these like cracks, where there would be a lot of natural gas. It's a pressure thing. So as this is pumped down into the well, it creates a lot of pressure that causes these cracks. And then the sand and the chemicals can kind of hold open these different like little fissures so that natural gas can escape. So this chemical or this fracking fluid is used to open up these cracks, hold them open so the natural gas can then escape and is pushed up the well. Okay, so that's kind of how fracking works in a nutshell. There are tons and tons of issues with this, tons of potential risks that you can contaminate groundwater, this stuff up here. So let's say there's like a little leak and then all that natural gas, all the chemicals, all the sand get into our drinking water. So that's a huge potential risk, and we're already seeing that kind of stuff happening all over the place. It also requires tons and tons and tons of water. 70 to 140 billion gallons of water are used each year, which doesn't seem like that much, but it's, if you look over here, equal to the annual water consumption of 40 to 80 cities with a population of 50,000. So it's a ton of water being used. There's a lot of risk to it. It damages our planet, and it's just not good. But it's really cheap, and we're doing a lot more of it now. But I'm going to get a little bit more into why it's a little bit fracked up. So it contaminates drinking water. This is a real sample of drinking water, from Pennsylvania, similar to the Flint issue, but the fracking contaminates water and makes it toxic to humans. There's tons and tons of protests about fracking, lots of great signs. And this is what fracking land looks like. So it's destroyed. You take an area and you just mine it to death. You drill it to death. You drive trucks all over it all day long until you're left with this ugly piece of land that's no longer natural or beautiful. You can also have massive explosions on the fracking sites, so the well can explode, bad things can happen, there's tons of fires, and people can get hurt. And another interesting thing that is not really publicized very much, but in areas where there's been a lot more fracking, there's a lot more earthquakes. So my aunt lives in Oklahoma, and she herself has experienced way more earthquakes in recent years than she has in the past, and that's because these fractures in the ground, in the rock, can actually have an impact, and they can create an earthquake. So this was the amount of earthquakes that existed from 1980 to 2009 in central Oklahoma. and this is 2014 to 2015. So that's just 1 year compared to, what is that, like 30 years of earthquakes. This is 1 year of earthquakes. There's so many more earthquakes due to the high amount of fracking in Oklahoma because there's a lot of natural gas in Oklahoma. So we're creating earthquakes, we're creating fires, we're damaging land, we're poisoning water, all for this resource that we could find an alternative for. It's fracked up, in my opinion. Okay, we're almost done. I want to talk about this special place because it's often on the test. The Arctic National Wildlife Refuge, or ANWR. It's this amazing, beautiful land in Alaska. It's protected. It's been protected by the U.S. government since 1980. It's beautiful. Look at it. And it also has one of the largest herds of caribou here. So those are all little caribou or large caribou. It's a huge breeding spot for many animals because it's this beautiful protected land. There's polar bears, there's birds, all that stuff. And it's been protected for a long time. But our current administration is trying to develop a certain part of it to drill for oil because there is a lot of oil there. But it's been protected for a long time, so people are freaking out about it. But on the counter side, it would not contribute a ton of oil to America, so you could say it's not even worth it. But also, if you look over here, this is the entire refuge. This is the area they're trying to develop, and this little red dot is the actual proposed development site. So, not a massive, destruction of the entire refuge, but I think it brings up the question of if you do this in one little area, why not the entire thing? And then we start to lose our protected lands, our national parks can come into question. So this, I think, is a huge, debatable point. If we have these protected lands, can we just make them unprotected because we want oil, we want natural gas? Where does it end? So it's a really interesting topic. Might be on the test this year, who knows? But just cool to know about. Maybe some of you will go visit one day and send me pictures. Okay, last topic, and it is the toughest one, sadly. And it might be on the test. So we're going to talk about nuclear power. I'm going to try and make it quick. I'm sorry if it's confusing. So again, I'm going to try and make this simple. Don't panic if you don't fully understand it. But we're going to talk about nuclear reactors. So the element used for nuclear power is called uranium. And there is a specific type, so it's uranium-235. That is the naturally occurring element. It's really radioactive, meaning it's very toxic. And because of this, you have to use a lot of precaution when you're using it to create energy. So the uranium is placed into these fuel rods, which are right over here. They're all these silver colored rods. The uranium goes in there, and when it's placed in there, a reaction occurs called nuclear fission. So nuclear fission is basically when the uranium is in these fuel rods, the nuclei of the actual element itself, of the uranium, they collide and they break apart into smaller nuclei. And in that process, they release a ton of energy and release neutrons that keep the reaction going and going and going. So this process is similar to oil and coal when their hydrocarbons are split when they're heated. They create a lot of energy. Same thing with this. So uranium gets, the nuclei are broken and split, makes tons and tons of energy. That energy that is used in the vessel that has the fuel rods. So these are the fuel rods here. Energy is created and it's pushed into a steam generator. Same process that we've already seen. The water that's in the steam generator is turned into steam using the energy from the fuel. So the steam is generated and there's a lot of pressure that pushes the steam here and then turns a turbine. Okay, so that steam then turns a turbine that powers an electrical generator, and that generator powers all of our city, our whole planet. Not our whole planet, but it powers an electrical grid and creates energy, or creates electricity. So that's basically, in a nutshell, really simple. Don't worry too much about this other stuff, but it's almost the same process, except that uranium has to go in these fuel rods and undergo nuclear fission. There are also something super important that might be on the test called control rods, and they're also similar looking. They're these guys here. Sorry, these ones up here. And they're inserted in between the fuel rods, and their purpose is to absorb excess neutrons that are released during the reaction of fission, which slows down the reaction. And if they didn't exist, then the reaction would go on, and it would be uncontrolled, unstable, and you would have some sort of disaster on your hands. So you have to have those control rods to ensure that you can slow down and stop the reaction of this radioactive element. You don't want to mess with it. Things go wrong, which brings me to Chernobyl. Very briefly going to talk about it. A massive accident, a lot of conspiracy around what actually happened, but there was a safety test, miscommunication between a lot of different people that were in the actual power plant. Things were left open. a lot of energy was released in one of the reactors, and that created a massive release of radioactive material, which created explosions and then radiated throughout the entire city. They made a show on it. I hated the show, but if you want to watch it, it's on HBO, I think. It's called Chernobyl. And this was in the Ukraine, in 1986. So it's just interesting to know about. There have been a few other radioactive disasters, but none of them have been as bad as Chernobyl. And that is it for this incredibly long video. I hope you stayed with me because I think it is really interesting stuff, and I will be filming part 2 shortly. Bye, everybody!